Okay, remember when it comes to parallel and perpendicular? So parallel have these same slopes, so equal slopes. Perpendicular are opposite reciprocal. Slopes. So lucky for us, they put everything in y equals mx plus b. So for here, my m is negative 1/4. Here, my m is a positive 1/4. And then here, my m is negative 4. So none of them are the same. So now I'm going to see if any of them are perpendicular, or I mean opposite reciprocals. And sure enough, so this one's positive, this one's negative. The reciprocal of 1/4 is 4. So line B and C are perpendicular. In a direct variation, okay, boom, direct variation. So I write down y equals kx. The function has no constant or b value. So they're thinking about y equals mx plus b. We already talked about for direct, the constant of variation is the same thing as slope, right? So your m and k is there. So if there is no b, remember we can just go ahead and put plus 0 right there. And that is the y-intercept. So the graph will always pass through the origin. That is a true statement. All right, what is the standard form of the equation? Okay, so first of all, they gave us 2 points. So the first thing that we can do is find slope. y2 minus y1 over x2 minus x1. So m equals negative 3 minus a negative 2 all over 1 minus 4. So this is now a positive. Negative 3 plus 2 is negative 1. 1 minus 3, or 1 minus 4 is negative 3. 2 negatives is a positive. So my slope is 1/3. All right, so I have a slope of 1/3, and I've got 2 points. I'm just going to grab the first point, 4, negative 2. So now I can go, I have a slope, I have a point, so I'm going to go to point slope. Okay, so y minus a negative 2, so y plus 2 equals 1/3 x minus 4. Okay, so I go ahead and I distribute, because this is point slope, right? If they asked me for the point slope, I would stop here. Now I distribute 1/3 x. 1 times negative 4 is negative 4. Negative 4 divided by 3 is just negative 4/3. And I subtract 2 on both sides. Y equals 1/3 x. Now, if you have no idea how to do that in your head, it's okay. This is negative 4/3 minus 2. So you can go to your calculator. Remember, fractions we put in parentheses. So negative 4/3 minus 2. Enter. What? What'd I do? Oh, look at me. I put a minus 4. Negative 4, oopsie doops, thirds minus 2. And then I math frac. So negative 10/3. So minus 10/3. This is now slope intercept form. I want to put it into standard. So I need x and y on one side, my constant on the other. So I'm going to subtract 1/3 x on both sides, giving me a negative 1/3 x plus y equals negative 10/3. Now, with standard, I cannot have fractions and a has to be positive. Currently, a is negative, so I need everything multiplied by negative. And then I multiply by the denominator, which is a 3. So I'm going to multiply everything by negative 3. Negative and a negative is a positive. 3 times 1/3 is just 1x, or just x. Negative 3 times y is negative 3y. And then a negative and a negative is a positive. My 3 goes away, leaving me with 10. This is now in standard. I have no fractions and a is positive. So x minus 3y equals 10. X minus 3y equals b. All right, the equation of the line shown is, all right, so remember, we always do y equals mx plus b. If there's not a plus b, go ahead and put plus 0. So here, if I'm looking at this equation, my y-intercept, my b, is equal to 0, and then my slope is rise over run. Before I even start counting dots, I'm going downhill, so I know it's going to be negative. And then I'm just going to put a point here. So I drop 1, 2, 3, 4, 5. That's why it's negative. And I go to the right, 1, 2. So now I can use my information. This is y equals negative 5 halves x plus 0. So plus 0 or just that. And sure enough, so that's true. When data has a negative correlation, okay, so if they give me something like this, I'm just going to go ahead and draw a graph. The dependent variable tends to something as the independent variable. So remember, independent ladies. So independent, us ladies, we are X, right? Dependent are Y. So X, so this is our independent variable. This is our dependent. We also know that it said negative correlation, right? So negative correlation is like negative slope. It has a downward spiral. Okay, so this is how I did it at least. The dependent variable tends to something. So the independent variable is increasing. So as this is increasing, do you see how your dependent is going down? So the more independent, the less the dependent value is. So it's going to decrease. In general, negative correlation, they both can't be going up, right? If it was a positive correlation, one gets higher, the other gets higher. The one increases, the other increases. Negative correlation is the exact opposite. Which equation has a slope of 5? You need to turn every single one of these into y equals mx plus b. So let's start with f. 10x minus 5y equals negative 10. Subtract 10x on both sides. And divide both sides by negative 5. So y equals negative negative is a positive. 10 divided by 5 is 2x. And then negative 10 divided by negative 5 is also positive 2. So this one is y equals 2x plus 2. So my slope is 2. All right, let's do g. So this was f. Here's g. 3x plus y equals 5. Subtract 3x. Y equals negative 3x plus 5. So on this one, my slope is negative 3. Lucky for us, H and J, they already put in slope intercept. So that's negative 5, and this one is a positive 5. So which has a slope of 5? J. All right, if the graph of y equals 5x plus 2 is shifted down 5 units, which is the new equation of the graph? Okay, honestly, if I were you, I would just put these into my calculator. So go to your calculator, go to y equals, clear anything you currently have in there. And the original equation that they just gave us was 5x plus 2. So 5x plus 2. You're not going to change that one. Now I would test my other ones, my other equations. So the next equation was 10x plus 2. All right, so if I go in here, 10x plus 2, graph. Okay, there's my first equation. That's my second. Okay, so that did not shift up 5 units. That just, or down, whatever it said. It crisscrossed, it did all sorts of weird stuff. So that's definitely not true. What it was, okay, down 5 units. So let me go to B, 0x plus 2. So I'm going to keep my first equation in there because that's almost like my parent function. Okay, so 0x plus 2, graph. There's my first one. What happened? Oh, because I put 22. Sorry, guys. 0x plus 2. Delete. Okay. Okay, that definitely, that's a horizontal line, so that doesn't make sense, so no. 5x minus 3. Second one. 5x minus 3. There's my first function. There's my second. That's looking pretty good. So I'm going to keep it there. And then my last one is 5x plus 6. 5x plus 6. And that one shifted up. So they wanted me to go down. So that can't work. So C must work. The reason is this is your y-intercept. So you can take that exact same line and move it up or down by just moving the y-intercept. So if I just sketch this real quick, let's use this little guy. So currently plus 2, it looks something like that. We wanted to shift it down 5 units, so all I could do is 1, 2, 3, 4, 5. So you're just changing where the y-intercept is, but the slope is not changing at all. So if you want to shift it down 5 units, you just subtract 5 by the b, giving you y equals 5x minus 3. That's why. All right, choose the equation for the line that best fits the data in the graph. Now, there's a couple ways you can do this. You can take every single point, put it into your calculator and to the list, and then do your linear regression. Or you could just use common sense, really. So let's go ahead and draw our line of best fit. A line of best fit just means the line that goes through the points. There's some above it, some below it, but it's pretty close in there. So now y equals mx plus b. Okay, my b is around 8.5-ish, so 8 or 9. So I'm just going to put 8-ish. And then I don't really know what my slope is. I could say down 1, run 1, like this, right? M is rise over run. But at a very minimum, you should know this is a negative slope, right? So I'm just going to take the point right here. So I fell 1, which is why it was negative, ran 1. So that's a slope of -1. So 1, you could put a 1 there or just keep it as negative x. And if you look, boom, there it is. Right? Just knowing that that's a negative correlation, which is the same thing as negative slope, you could have gotten rid of G and H. And then there's no way that it was going to cross here at 5. That's way too low for the plus 5. All right. Y varies inversely. If you see inversely, you immediately write the equation. Y equals K over X. All right. So when X equals 4 and Y equals 3/4. Okay, I've used that. I'm going to go ahead and cross it out so I don't get confused later. By the way, this should say when x equals 6. All right, so x divided by 4, the opposite of dividing by 4 is multiplying by 4. K equals 4 times 3 is 12. 12 divided by 4 is 3. So now I have my K, and I plug it in there. So my equation is y equals 3 over x. Okay, so now they want to know what y is when x equals 6. So all I do is just plug in 6 right here. So this is now y equals 3 over 6, which reduces down to 1/2. All right, y varies directly. I see directly, I immediately write y equals kx. All right, so x equals 4 and y equals 3. Okay, so they just want us to find the constant variation. So all we have to do is get k by itself. So k equals 3/4. Boom. All right, examine the values in the table. Determine if y varies directly, inversely, or neither. Okay, so direct means divide. So that's y over x. Inverse, we multiply. So that's x times y. So the easiest thing I think is multiplying. 0 times 3 is 0. 6 times 51 is not 0. So it's definitely not inverse. So now I have to determine if it's direct. Remember, it's y over x. So 3 over 0, that's undefined. 51 over 6 is not undefined. So it can't be direct. So this is a neither.